This quiz review handout looks exactly like your quiz tomorrow. It's very similar types of questions, a very similar layout. If you can do this quiz review, you should be able to do your quiz tomorrow. So, what we're going to do now is pause the video. I would like you to try the review sheet. Do as many problems as you can, work at them in your group, help each other, and then when we're all done, you can either watch the video tonight to check your answers, or if there's time left at the end of class, we can unpause the video and the substitute will show you me doing the problems. When you study for math, the person doing the work is the person studying and the person learning it. I could do this whole review sheet for you in the beginning, but that's not you practicing and you studying. You as the student need to be doing the problems, and you as the student need to be putting in that practice pencil to paper and doing the math to get the practice to master the skill and master the material to then perform on the quiz or the test. So with that, we'll pause it here and you can get started. Okay, so to prove using algebra that xy is the original and yx is on the inverse, we have to do two things. First, we have to show that the segment connecting xy to yx is perpendicular to the line y equals x. And second, we have to show that the segment is bisected by y equals x. And here's how we are going to do that. For perpendicular, for A, we have to show that the slopes are negative reciprocals. The slope of y equals x is 1. That's a really bad M. I know that because it's y equals mx plus b. The slope right here is 1. So now if I find the slope between the 2 points, I want that to be -1, or the negative reciprocal. So we're going to take this point and find the slopes. I'll call this one x1 and y1. I'll call this one x2 and y2. So that is y2 minus y1 divided by x2 minus x1. And remember, our goal is to get to -1. What I notice in the numerator is we have x minus y. If I can get x minus y in the denominator, anything divided by itself is 1. So what I'm going to do is switch the order. I haven't changed the signs yet, but so that I have x and then y. And then what I notice is that I can factor out a negative from the denominator. And factoring out means divide out, but then it's written as the coefficient. And now this is very exciting. We're almost there. X minus y divided by x minus y is 1. And we're left with 1 over -1, which is -1. So to show that the segments are perpendicular, the slopes are negative reciprocals. Therefore, the segment is perpendicular to y equals x. And now we're going to have to show the bisector. So to show that the segment is bisected by y equals x, we want to show that the midpoint is on the line y equals x. So that means for part B, to find the midpoint, That's the average of the endpoints. So we're going to add up the x-coordinates and divide by 2, add up the y-coordinates, divide by 2. So that's going to be x plus y, and then y plus x. Well, I notice that if I write them in the same order, because y plus x is the same thing as x plus y, that both my coordinates are the same. So because the x and the y coordinate are the same, that means the midpoint is on the line y equals x. Because the midpoint's on the line y equals x, that means that that line is in the middle and it bisects your segment. So now for number 2, using the verbal description, write the function and then its inverse. Explain the strategy you used. Okay, so for f of n, I'm going to take n, multiply it by 3, square the quantity, and add 8. So to write the original function I, followed the steps. First, my variable n is multiplied by 3, then the quantity is squared, and lastly add 8. So for the inverse, first I'm going to do a little bit of work on the side. First we had n, then we multiplied by 3, and then we squared it, and then we add 8. So going backwards, subtract 8, square root, divide by 3. So my inverse is going to be n minus 8 square rooted all over 3. To write the inverse I, determined the steps to go backwards. First, I subtract 8 from n, then square root the quantity, and divide by 3. Okay, so for number 3, Reggie inputs the number 17 into the function machine. What result would the final output? How do you know? Okay, so what they're telling us here is if we put in 17, we get some value, then we take that value into the inverse, what are we going to get? So the final output result will be 17. I know this because function 1 and its inverse undo each other so that t is also the final result. Okay, for number 4, determine the inverse and explain how you did it. Okay, so for A, first we had x, then we multiplied by negative 2/3, so negative, and then we take that minus 5. Going backwards, we're going to add 5 and multiply by negative 3/2. So that's going to be x plus 5 all times negative 3/2. Making that look nicer, I'm going to put the negative 3/2 as a coefficient, so I don't think it's subtract 3/2. I determine my inverse relation by laying out the steps to go backwards from the original g of x. So the general theme here, inverses are the backwards. Okay, so now we have a set of coordinates and I want the inverse. So when you have a set of coordinates, what we're going to do is reflect them over the line y equals x, which means the coordinates all become y comma x. So this is going to be 4 comma negative 11, negative 2, negative 5, 2, negative 1, negative 1, 0, 8, 3, and 16, 9. I determined my inverse relation by reflecting all points over y equals x, and where's my eraser? Y equals x. This changes xy to yx. Okay, so now for this, I'm going to start, we had x, we made it x squared, and then 4x squared, and then 4x squared plus 5. So going backwards, subtract 5, divide by 4, square root. So that's going to be x minus 5 divided by 4, all underneath the square root. So I turn my inverse relation by doing the steps of the original function backwards. And now for D, I'm going to make all the k of x's x and all the x's the inverse. I determine my inverse relation by reflecting each point over y equals x, which changes x k of x to k of x comma x. So to graph the inverse, I'm going to first find some key points. So let's see. Negative 2, 2, negative 1, 0, and 0, negative 2. And then the inverse reflects those. And I'm a visual person. I like to see the coordinates written out, so then it's easier just to go graph 2, negative 2, 0, negative 1, and then negative 2, 0. And knowing that it's this S-shaped, help myself one more time. I'm gonna pick one more point just to see what the ends are gonna be like. Let's say this point here is a little more than 1, a little more than 0, negative 4. So that's gonna be negative 4, a little more than 0. All right, so now my S shape goes this way. To graph the inverse, I performed the following steps. I found key points and reflected them over y equals x to b y comma x. Okay, same thing for b. Let's do this point, this point, this point. So that is -1, -4, -1, -1, and 0, 2. Which changes to -4, -1. And then, let's see, graphing them. Oh, I had something wrong. Did you see this point down here is actually -2, -4, which is going to change this point. Not going to let me erase it, so let's just graph that here. And now here's my inverse. Ignore that point. I performed the following steps. I found key points and reflected them over y equals x. Okay, so now we have to write an equation. Anytime I see the word per, that is my slope. And any flat phi is my y-intercept. So her cost is going to be 1.093 times gas plus $17.26. She lost her bill but knows how much she paid. Write the function rearranging the original that will help her determine the reverse. If she had the cost based on, okay, so really what that's saying is find the inverse. So to find the inverse, first we had G, then we multiplied it by 1.093, and then we added plus the 17. So going backwards, subtract the 17, and then divide. So that is going to be cost minus 17.26 divided by 1.093. Explain your solution. You can use some of the same explanations we used before. I found the reverse of the equation, or I went backwards in the steps. Given her total bill was $412. So gas is $412.17. Okay, so calculating that number, explain your solution, including why the function created in B was used. Because we were given cost, I was able to plug that in to this variable to calculate it to get gas, which is why I used the equation in part B. Using the equation part A, I could have plugged the cost in here, but then I would have had to manipulate this around to isolate the G, which technically we already did by finding the inverse this equation. And to fill in the remaining answer, the gas is 361.31 BTUs. You have to label your answer. How could you use the original function to check your solution? There's two ways I could do that. I could plug 3.61 in for the gas variable in this equation and see if I get the same cost. And this works because the equations are inverses of each other, meaning the result of one plugged into the inverse will give you the original value that we started with. You'll notice at the end of the review, it says 2 additional points will be based on your ability to abstractly and quantitatively reason. That means we will be grading your explanations and we will be grading your complete sentences, and that we are grading how clearly you can express your ideas on the quiz.